So I have this mini switch here that just kind of hangs off the top shelf of this shelving unit I built. I'd like to better secure it to the top shelf here. To do that, these switches have little holes here for screws to hook on. Now I could just put 2 screws right through this top shelf and have it hook on, but I don't want to put holes through the top shelf here. So I think what I'm going to do is I'm going to model a 3D printed part that'll slide into this top shelf with holes in it, and then just have screws that will attach on. I'll make 2 of them. That way I can just slide this thing on and it'll be held in place like so instead of just kind of hanging off there. We're going to open up MS Paint now and just do a rough sketch of what this piece should look like. It'll look something like this. We'll have a hole there for that screw to stick out, and then engage on the switch to hold it in place. So for parameterized design in OpenSCAD, I need to find some dimensions here. So I think the width here, I want to have 5 millimeters. The length from the back of the piece to where that screw hole is, I'm going to have that be 33 millimeters. The whole piece length in this dimension is going to be 50 millimeters. This gap here to slide onto that 3/4 inch top shelf piece, 3/4 of an inch is roughly 19 millimeters. It's actually 19.05. I might just make it 19.5. Another dimension we need is the diameter of this hole here, and I can measure that later, but it's just going to be roughly the diameter of that screw, and it's going to be a little bit smaller than the diameter of that screw just so that it can grip in decently with the threads. So let's now fire up OpenSCAD and start on the actual design. CSD, corner sphere diameter, I'm going to set that to be 1. What I like doing is using spheres to make a sphere hull for any pieces I make, just to make it look a little bit more polished and finished. So there's our starting sphere piece. So back to my illustration here, we need to figure out what this width should be. And I'm just going to say maybe 15 millimeters to start out with. We can always play with that because we're going to be doing a parameterized design. So if we need to make it wider, we certainly can. So we'll call this clip width. I'll just say clip W equals 15. And all the units are in millimeters, of course, in OpenSCAD. So I'm going to want to translate this clip W divided by 2 in both directions of the x-axis. And we'll create our second sphere. Now the true width is going to be a little bit different here just because the radius of these spheres. So I need to take that into account. So I need to subtract the radius of each of these spheres, or just the diameter of them. But on each one, I'll just do the radius. So I'm going to subtract clip W divided by 2. Well, actually, it's CSD. CSD divided by 2. And then CSD plus in the negative direction. Just flip the sign around. And now from the edge of this sphere to the edge of this, to the point on those extremities, is going to be 15 millimeters. And we can even count it. 1, 2, 3, 4, 5, 6, 7.5. 7.5 times 2 is 15. Now back to our illustration, we have the length of the piece, 50 millimeters, so we'll call this clip L. Clip L equals 50. And we're going to duplicate these spheres and translate them out 50 millimeters. So that's going to be in the Y direction, so we're going to say clip L. And there they are, 50 millimeters out. But again, we have to do the same thing with the corner sphere diameter and subtract or add the half of the diameter or the radius. So right here, I want to push these spheres in this direction by the corner sphere diameter divided by 2. So the ones I translated out are right here and here. It's these two that I want to translate in the Y direction by CSD divided by 2. So in the Y direction, I go CSD divided by 2 and CSD divided by 2, hit refresh, and now these spheres, at least in the y-axis, are on the edge there. And similarly with these two spheres, we see they are straddling the 50 millimeter mark there. I want to move them back by CSD divided by 2 in the y direction. So CSD, it's going to be minus CSD divided by 2. And now this is going to form a 50 millimeter long piece. Now let's tackle the z-axis. So I have the xy plane here. I need to have another set of 4 spheres so that I can make this a 3-dimensional piece when I create the sphere hull. So I'm going to take all 4 of these spheres, copy and paste. Now if I go back to my illustration here, another dimension we need here, another measurement is kind of this right here. So this is actually determined by the gap here plus the 5 millimeter. I'm going to go 5 millimeters this way and 5 millimeters this way as well. So this is going to be 19.5, which is this length, plus 5 plus 5. So that's just going to be 29.5 and then millimeters. So I think what I'm going to do is I'm going to translate this up 29.5 millimeters, and then we'll cut out the portion that will be for where it slides into the top of the shelf. So I'm going to translate these spheres up by CSD divided by 2 in the Z direction. So CSD divided by 2 for the bottom 4 spheres. And then for the top 4 spheres, I'm going to translate those up. So we'll call this clip height, clip H, is equal to 29.5. And let's label our variables here. So it's clip H in the Z direction, but we also need to subtract CSD divided by 2. So that moved these spheres just sitting right atop the XY plane. And then we also have the other 4 that we created translated up by 29.5 millimeters and then subtracted off the CSD divided by 2, so that from the top of this sphere to the bottom of this sphere should be 29.5 millimeters. And we can easily test that by just changing this value to, say, 10, hitting refresh, and we see right at that 10 millimeter mark, it's lining up there. And to even get a better view, we can go to the orthogonal view. We see very clearly there that that is right on the money. Switch back to the perspective view and change this back to 29.5 millimeters. Now if I create a sphere hull, so I just create a hull of all 8 of these spheres, we'll start to get the general shape we're looking for here. So what I'm going to do is I'm going to cut out the portion that's going to be sliding into the top of the shelf. And I think to save on some plastic, I might even cut off a little bit more. What we could actually do is create, if I take this hull off, if I move these points back, these 2 bottom ones, say maybe to here, and then create another set there, I can then save on some plastic used to print out this piece. That will complicate things, though. We'll have to have probably 2 different hulls then, which that's okay. So these 2 spheres right here and here are on the bottom. Let's see if we can identify them. Yeah, it's that one and that one. So these 2. I'm going to call this clip length reducer, so clip LR. And we'll say, let's reduce it by 20 millimeters. So we'll just subtract that off the Y direction. So that moves these 2 spheres this way in the negative direction on the y-axis by 20 millimeters. And if we re-enable our hull, we get this piece. Now we could refine this a bit and put spheres here, so it's not this angular shape when it slides in. So we could put a couple of spheres here. So I'm going to take these 2. I'm going to not subtract the clip LR, and then in the Z direction, I'm going to go clip H divided by 2. Just to put them right about here. So now when I cut out that piece, I'm going to have an angular section there, which is okay. That's going to be more concealed because it'll be on the underside of that shelf piece. But here we'll get a non-angular, non-sharp end there. So let's now create the cube to cut out from this piece. So I'm just going to indent a little bit here just to make this look a little bit more neat. So we have our cutout piece. So I'll call this CO width, cutout length, cutout height. So the cutout width, we'll just say 70. Doesn't matter too much. Cutout length, again, it doesn't matter. As long as we line it up to where it needs to be, we could just have these be overflowed pieces. Cutout length. Now the cutout height will matter here. It's going to be 19.5 millimeters. Cutout height. So we're going to define this cube and then translate it where it needs to be. So cube. So the cutout width is in the X direction. Cutout length is in the Y direction. And then cutout height is in the Z direction. So there's our cutout piece. Now we need to place it. Let's also change the color here. We'll make it this color, this kind of translucent. So first let's center it on the X axis. So we're going to go translate and then COW divided by 2. In the negative direction, so there it is there. We need to now translate it in the Y direction. That should just be 5 because we have a width of 5, the wall width. Let's define that too. We'll call that clip thickness, so clip T. And then because we need 5 millimeters of thickness on the bottom portion, we're just going to do clip T again to translate it up in the Z direction by 5 millimeters. Now let's actually cut this piece out from our main piece. So we'll use difference for that. So it's going to be the difference of this hull and this cube. So difference between the hull and the cube should equal this piece we're looking for here. So now we need to place the hole for the screw to be that will grip the switch in place. Back to our drawing, that's going to be 33 millimeters from the edge to where the hole should be for the screw. We'll call this screw hole Y offset. Screw hole Y offset will be equal to 33 millimeters. And this is going to be a cylinder that we'll be cutting out from the piece. Now I'm going to make a union here because this is our base piece, and then we cut out the cube, and we'll also cut out the screw hole as well. So we'll make a union here and combine our subtracted pieces. So our screw hole cutout will be right here. Cylinder, so the height, and then we also have to define the diameter. I'm going to say diameter just 3 for now is kind of a placeholder. We'll say 2.5. And then the height we'll say 4. Just a guess for now. We can fine tune those values once we measure the screw. And then we need to translate this to where it needs to be. So it's going to be right here for starters. We need to translate it up by the height of the piece and then out by the screw hole Y offset. So let's do the screw hole Y offset first. In the x-axis, it's going to stay with an x value of 0. So x is 0 on that translate. The y is going to be this SHYO value. And then the z value is going to be the height minus the depth of that screw hole. So we'll just start with the height. That would be the clip H, the height of the whole clip piece. And let's see how this looks. Now, I'm going to subtract 1 so we can see where that screw hole is. So we moved it up and then out by 33 millimeters and then down by 1 millimeter. So now I'm going to measure the screw and make sure that my diameter of the screw hole is good and also the depth as well. A diameter of 3 millimeters should work out well. So we'll go screw hole diameter is equal to 3. And then our screw hole depth, SHD. Now, one thing I'm not really a fan of is this sharp edge here. I think what I'd like to do is I'd like to have this just be a right angle. So to do that, we'll take this difference operation off at the moment, and we'll also make this translucent. So to do what I want to do here is going to complicate the design a little bit. What I'm going to do is I'm going to have 2 hulls, and we'll still be cutting out from both hulls, but I'm going to have a hull on the top and a hull on the bottom. That way they're not linked together and form this angular shape here. All right, so what I did there is I took the top portion and then made the bottom portion of that hull just be down half of the height of the piece. It's a top hull and a bottom hull, and I'm just going to be cutting from both hulls at the same time. So to do that, I need to make these hulls a union. So now these hulls are both treated as one piece, and I'm going to subtract from them the cutout cube as well as the screw hole. So that's more the piece I'm looking for. And I want to maybe create a bit more of a curve here so I can play with the CSD value. If I change that to a 2, that'll give more of a curve to those edges, make it look a little more smooth and polished. And if I want to play with the thickness of these 3 pieces here, I can just play with this clip T value. Probably don't want to go too small. Now here we actually have a issue. I presume that 5 millimeter value, but that would also affect the height as well. So the clip height is actually dependent on clip T and the cutout height. So the cutout height is 19.5. So really wherever we have clip H really should just be this COH plus clip T plus clip T. So I'm going to change that back to 5. So let's go ahead and print this out and see how it works. But first I need to render it. So I'm going to press F6 to render. And then we'll export to an STL file. And let's proceed with printing this out now. I have the piece loaded into the printing software. We'll initialize the printer. I also have my 3D printer camera connected here. So I'll have the platform warm up here until it gets to be, I think, 70 degrees Celsius. Works pretty well, I think, for the platform. and we'll get this piece printed out. See how it works out. So let's give this piece a try. So it does work, though an issue is that the hole depth, the screw hole depth, isn't great enough for this length of screw, so I need a shorter screw to hold it better. So I found a shorter screw that fits the hole of this switch decently. So now it should just be a matter of printing off another one, attaching it, and it should be good to go.